Okay, so I just wanted to touch base with you about some introductory trig concepts that you might need refreshed. So for the most part, I thought we would start with what most people take away from high school trig classes, and that's that most people remember the basic trig ratios, and they usually remember SOHCAHTOA. So this is where we're looking at a right triangle, where this is our angle theta. And we think of the side opposite theta, we call the opposite. Next to theta, the adjacent. And then we always call the side opposite the right angle the hypotenuse. So we define sine of theta as the ratio of the side opposite over hypotenuse. And we define cosine theta as the adjacent side over the hypotenuse. And then tangent is opposite over adjacent. There are three reciprocal functions. So the reciprocal function for sine is cosecant. So cosecant theta is then, again, we just flip hypotenuse over opposite, secant theta, hypotenuse over adjacent, and cotangent theta as adjacent over opposite. So if, for the most part, we remember two basic special triangles, special right triangles, and that is your 30, 60, 90 and your 45, 45, 90. So your 30, 60, 90, our sides are 1, 2, square root 3. And again, remember the smallest side is opposite the smallest angle. The largest side is always opposite the right angle because that's the largest angle. So 1, 2, square root 3, your 45, 45, 90, the sides are both 1 and the hypotenuse is the square root of 2. Remember, this could all be verified using Pythagorean theorem as well. So with this, then I know that sine of 30 degrees is again opposite over hypotenuse is 1/2. Cosine of 30 degrees is square root of 3 over 2. And then tangent would be opposite over adjacent, or 1 over the square root of 3. Often you'll see these rationalized, so the same would be radical 3 over 3. And again, we can do the same thing with the 45 degree angle or the 60 degree angle. But this is one way to come up with all of those values, and that's a big part of this. You'll be asked to find exact values for the basic trig functions of these special angles. Now, where this doesn't help as much is when we're looking at your quadrantal angles, meaning your 0, 90 degrees, 180 degrees, 270, or any angle that is not acute. So it's also helpful to think about the unit circle. So unit circle, I'm going to draw an XY plane, and then bear with me with the my sketching here. So I'm going to try to draw a circle that is decent. Not too bad. Let's pretend that this is the exact middle, which is the origin, or 0, 0. And since this is a unit circle, that means the radius is equal to 1. So basically from here to here is 1 unit, which means this point would be 1, 0. And if I think this point would be 0, 1, this point would be negative 1, 0, and this point would be 0, negative 1. So now it's helpful to come up with multiple points around the unit circle, and we're going to look at trig functions this way. So for example, let's take this point on the unit circle. And I'm just going to call it AB. All right, so let's draw an angle through that point. So just for some basic vocabulary, so this angle, I'm just going to call theta, would be a positive angle. So it's also in standard position. An angle in standard position means we call this the initial side. The initial side, and we call this the terminal side. So basically, because this is where it starts and this is where it stops. So an angle is considered to be in standard position if the initial side is on the positive x-axis. So when we go up this in this direction, so that would be what? Counterclockwise. That is a positive angle. If we were drawing an angle down this way and looking at it like this, that would be a negative angle. So if we're looking at a positive angle, and again we call this AB, we can use what we talked about with the right triangles to define our trig functions. So let's drop an altitude here and draw a right triangle. So if I bring an altitude down like this, then basically to get to this point up here, I would go over, if this is AB, and I would go over A units, so this would be A units, and I would go up B units. So this side would be B. So now if I want to look at, let's say, sine of theta, it would be opposite, which is B, over the hypotenuse, which we know since this is a unit circle, is 1. So sine theta is equal to B. Cosine theta would be adjacent, which in this case is A, again over the hypotenuse, which is 1, or A. So really this ordered pair can be thought of as cosine theta, sine theta. And I can think of tangent theta as either sine theta over cosine theta or B over A. So I can think of this like, let's say that this theta was 30 degrees. So if this theta is equal to 30 degrees, then what is this point? Well, we already decided, we know that sine of 30 is equal to, because we looked at that up here, so sine of 30 is 1/2, and cosine of 30 is the square root of 3 over 2. So that means that this point, if theta is equal to 30, would be the cosine value, which is square root of 3 over 2, comma, 1/2. And again, that also makes sense if we're thinking about that special triangle we looked at above. Remember, when this is 30, we said that this was 1 to square root of 3. So if we think about that with respect to our unit circle, remember the radius was 1 if it's a unit circle. So if I divide this by 2, that would make that 1. But if I divide this side by 2, I also have to divide this side by 2 and this side by 2. So again, thinking about those ratios, sine of 30 would be 1/2 over 1. So that's one way to come up with that point. Really, to come up with other points, I can just think about basic symmetry on the xy plane. For example, if we go across here and just think about this point, but now reflect it about the y-axis, that would mean that in this direction, I would go over square root of 3 over 2. So that would be negative square root of 3 over 2. And it would still be up 1/2. So that would be this point. And again, what would that angle be? So if I'm thinking about symmetry, that means that this angle would still be 30 degrees. But now what would that make this angle? So that would be, since it's 180 all the way over to the other axis, this would be 180 minus 30, or 150 degrees. So that means that sine of 150 degrees is equal to, again, the y-coordinate, which would be 1/2, and cosine of 150 degrees would be equal to negative square root of 3 over 2. And we can again apply that same logic to come up with a point down here using symmetry and a point down here using symmetry with respect to the x-axis, and look at those angles respectively. I'm going to stop this video here, and I'm going to start the next video with a blank unit circle that we're going to take a couple minutes to go ahead and fill in, and then take this again a little bit further.